All right, let's dive into blockchain today, but not just any blockchain. We're talking about private blockchains, the kind that are really like changing the game for companies
Right.
behind the scenes. You've probably heard about public blockchains
Right?
like Bitcoin, but private ones are a whole different ballgame.
Yeah.
Think of it like this. Public blockchains, it's like a bustling city, anyone can join the party.
Okay.
Private blockchains, more like an exclusive club, strict guest list,
Yeah.
customized rules. Right.
And that customization is key. Private blockchains offer a level of control that's incredibly appealing to organizations. Imagine a company being able to tailor a blockchain specifically
Yeah.
to manage its supply chain
Okay.
or to securely share sensitive medical records within a hospital network.
Okay, that makes sense, but if you're putting so much trust in this private system, you better be sure it's rock solid, right? I mean,
Yeah.
a blockchain glitch in a hospital network, that's not something you want to mess around with. That's where testing comes in, right?
Absolutely. Testing a private blockchain. It's like putting it through a rigorous series of checks and balances to ensure it's reliable, resilient, and secure. It's about avoiding those oh no moments before they even have a chance to happen.
So it's not just about making sure the software runs smoothly.
Right.
We're talking about testing the entire system, making sure it can handle the pressure
Yeah.
and do exactly what it's supposed to do, no matter what.
Exactly. And the stakes are even higher in a private blockchain environment because the decisions made based on the data
Yeah.
in these systems can have a significant impact. We're talking about things like supply chain disruptions, financial transactions, even healthcare decisions.
Okay. I'm starting to see why testing is so crucial here. But where do you even begin? What are the key components of a private blockchain that need to be thoroughly tested?
Let's start with something called the consensus mechanism. This is the process that ensures everyone in the network agrees on the state of the blockchain, even if some participants try to game the system. In private blockchains, two common consensus mechanisms are proof of authority, POA, and practical Byzantine fault tolerance, PBFT.
Okay, those sound intense. Break those down for me. How do they work, and why are they so important for private blockchains?
Well, imagine you have a group of trusted validators. Think of them like highly respected members of the network. In POA, these validators take turns, proposing and validating blocks of transactions. It's efficient and works well when you have a high degree of trust among the participants, which is often the case in private blockchains.
So it's like having a small council of experts who everyone trusts to make the right decisions.
Exactly. Now, PBFT is a bit more complex. It's designed to handle situations where some validators might be unreliable or even malicious. It involves multiple rounds of communication and voting to ensure that, even if some validators try to disrupt the network, the system can still reach a consensus and continue functioning.
That sounds like a pretty robust system, especially if you're dealing with sensitive information or high-value transactions.
It is. And choosing the right consensus mechanism is just the first step. We also need to make sure those smart contracts we talked about earlier.
Right, the rules of the game. I remember you comparing them to a vending machine. You put in your money, select your snack, and boom, the right snack comes out.
Precisely. But what if the vending machine malfunctions and gives you the wrong snack? Or even worse, doesn't give you a snack at all? That's why smart contract testing is so important. We need to make sure those lines of code are airtight, that the logic is sound, and that they execute as intended every single time.
I'm seeing a pattern here. It's all about anticipating problems and making sure the system is bulletproof. So what else is on the testing checklist?
Another crucial aspect is node synchronization. All the participants in a private blockchain need to have the same up-to-date information. Imagine a shared document where multiple people are making edits simultaneously. If those edits aren't synchronized, you end up with conflicts and confusion.
So it's like making sure everyone's on the same page, literally, and that no one's version of the blockchain gets out of sync.
Exactly. In a private blockchain, discrepancies between nodes could lead to disagreements about transactions, data integrity issues, and a whole lot of headaches. So testing node synchronization is essential to maintain the overall consistency and reliability of the system.
Okay, so we've covered consensus mechanisms, smart contracts, and node synchronization. What else do we need to put through the ringer, so to speak?
Let's not forget about data privacy and access control. This is especially critical in industries like healthcare and finance, where sensitive information is being stored and shared.
Right, you wouldn't want just anyone peeking into your medical records or bank statements.
Exactly. Testing data privacy and access control ensures that only authorized individuals can access specific data, and that every access is logged and auditable. Think of it like a high-security vault with multiple layers of security and a meticulous record of who enters and exits.
So it's like having a digital fingerprint for every interaction with sensitive data, which is reassuring, especially if you're dealing with confidential information.
Absolutely. And as we delve deeper into the world of private blockchain testing, you'll see how these layers of security and rigorous testing methodologies work together to create a system
Yeah.
that is both innovative and trustworthy.
Okay. It's becoming clear that testing private blockchains is serious business. We're talking about multiple layers of security and complex mechanisms all working together. But how do you actually go about testing all this? What does that process even look like?
Well, there's a whole range of testing methodologies designed to address different aspects of a private blockchain. Think of it like a toolbox with different tools for different tasks.
Okay, so what kind of tools are we talking about here? Give me the rundown.
Let's start with functional testing. It's like a test drive for your blockchain.
Okay. You want to make sure all the basic functions are working as expected. So making sure transactions go through, data is stored correctly, and those smart contracts are executing flawlessly. Basically ensuring the blockchain is running smoothly.
Precisely. But we also need to push this system to its limits and see how it performs under pressure. That's where performance testing comes in.
Okay. Imagine you have a private blockchain. That manages a supply chain.
Right. What happens when there's a sudden surge in demand, like during a holiday shopping season?
Yeah, you wouldn't want the system to crumble under the pressure of
Yeah.
all those orders and deliveries.
Right. Performance testing helps us identify bottlenecks, measure transaction throughput and latency, and ensure that the blockchain can handle peak loads without compromising speed or reliability. For example, we can use a tool like Hyperledger Caliper to simulate a high volume of transactions and analyze how the blockchain responds.
So we're talking about stress testing the blockchain to make sure it can keep up with the demands of a busy network.
Exactly. But performance is only one part of the equation. We also need to make sure the blockchain is secure.
That makes sense. You mentioned ethical hackers earlier. Are they part of the security testing process?
Absolutely. Ethical hacking, also known as penetration testing, is a crucial aspect of security testing.
Okay. We engage security experts to try and exploit vulnerabilities in the system, just like a real attacker would. So it's like a controlled attack. To expose any weaknesses before the bad guys find them.
Precisely. It helps us identify and address potential security loopholes before they can be exploited. But security testing goes beyond just penetration testing. We also look at things like encryption strength, access controls, and the overall architecture of the system to make sure it's designed with security in mind.
Okay, so we've got functional testing to make sure everything works, performance testing to make sure it can handle the heat, and security testing to keep the bad guys out. What else is there?
Well, we also need to make sure the blockchain can play nicely with other systems.
Right, because a blockchain doesn't exist in isolation. It needs to integrate with a company's existing IT infrastructure.
You got it. Integration testing focuses on ensuring that the blockchain can seamlessly communicate and share data with other systems, like databases, enterprise resource planning, ERP software, and even other blockchains. For example, if a company is using a private blockchain to manage its supply chain, it needs to make sure that the blockchain can integrate with its inventory management system and its shipping and logistics platform.
So integration testing is like making sure all the pieces of the puzzle fit together,
Right.
and that the blockchain is a good team player.
Exactly. And lastly, we have scalability testing. As the network grows and more transactions are added to the blockchain, we need to make sure the system can handle that growth without slowing down or becoming inefficient.
So it's like future-proofing the blockchain, making sure it can adapt and thrive as the demands on it increase.
Precisely. Scalability testing involves simulating different growth scenarios and analyzing how the blockchain performs. We look at things like transaction processing speed, data storage capacity, and overall network efficiency.
Okay, so we've covered a lot of ground here. Functional, performance, security, integration, and scalability testing. It's impressive how much goes into making sure a private blockchain is robust and reliable. But I'm curious, are there specific tools that are used for each of these types of testing?
Absolutely. We have a whole arsenal of tools at our disposal,
Wow.
some specifically designed for blockchain testing and others that are more general purpose.
Well, don't keep me in suspense.
Yeah.
What are some of these tools, and how do they make the testing process more efficient?
For starters, we have tools like Truffle and Ganache, which are popular among blockchain developers. Truffle is a development environment that allows developers to write, compile, and deploy smart contracts while Ganache lets them create a local blockchain instance for testing purposes.
So they're like a playground for
Yeah,
developers to build and test their blockchain applications in a safe and controlled environment.
exactly. It allows them to catch errors early on and experiment with different functionalities before deploying the smart contracts to the live blockchain network. Then we have tools like Hyperledger Caliper, which I mentioned earlier.
Right, Hyperledger Caliper is like a fitness tracker for blockchains, measuring how well they perform under different workloads.
That's a great analogy. It helps us collect valuable data on transaction throughput, latency, resource consumption, and other performance metrics, allowing us to fine-tune the blockchain and ensure it's optimized for its intended use case.
That's impressive. What about security testing? Are there specific tools for that as well?
Of course, there are tools like Mithril, which is an open-source security analyzer. For Ethereum smart contracts, it can detect common vulnerabilities, like reentrancy attacks and integer overflows, helping developers write more secure code.
So Mithril is like a spell checker for smart contracts, catching those pesky security bugs before they can cause any trouble.
Precisely. It helps ensure that the smart contracts are robust and resistant to attacks. Then we have tools like OWASP, ZZAP, a popular open-source web application security scanner, which can also be used to test blockchain applications that interact with web interfaces or APIs.
So it's like having a security guard for your blockchain application, making sure no unauthorized access or malicious activity gets through.
Exactly. It helps us identify and address security vulnerabilities in the application layer, ensuring that the blockchain remains secure and protected. And for integration testing, we often use tools like Postman or SoapUI, which are popular for testing APIs.
Right. APIs are those messengers that allow different systems to talk to each other.
Exactly. These tools allow us to test the API endpoints of the blockchain, ensuring that it can effectively communicate and exchange data with other systems.
It's amazing how many specialized tools there are. For testing different aspects of a private blockchain, it sounds like you need a whole team of experts just to handle the testing process.
Well, it does require a diverse skill set and a deep understanding of both blockchain technology and software testing principles. But the investment in testing is well worth it because it ensures that the blockchain is robust, reliable, and secure, which ultimately builds trust and confidence in the system.
Okay, I'm convinced that testing is an absolutely essential part of implementing a private blockchain. But can we see how this all plays out in the real world? Can you give me some examples of how private blockchains are being tested and implemented in different industries?
Of course, there are fascinating examples of private blockchains being implemented across a wide range of industries, from healthcare and finance to supply chain management and government services.
Well, let's dive into some of those real-world examples and see how this testing magic translates into tangible benefits for organizations and users alike.
Okay, so we've explored the what and the how of private blockchain testing, but I think what our listeners really want to know is like, so what? Why should they care about all of this? Like, what's the takeaway for them? That's a great question, and I'm glad you asked it, you see. Understanding private blockchain testing isn't just about becoming a tech whiz. It's about becoming a more informed citizen in a world that's increasingly reliant on this technology.
So it's like having a superpower, being able to see through the hype and understand how these systems actually work, and more importantly, if they're trustworthy.
Exactly. Imagine you hear a news report about a company using a blockchain to track sustainable products.
Okay. Or a hospital.
Yeah.
Implementing a blockchain to manage patient data. Armed with this knowledge about testing, you can ask the right questions.
Yeah.
Like, hey, did you actually test this thing properly? What kind of security measures are in place?
Precisely. You can cut through the marketing jargon and get to the heart of the matter. Is this system reliable? Is it secure? Has it been thoroughly vetted? It gives you a framework for evaluating the credibility of blockchain implementations.
So it's not just about understanding the tech. It's about understanding the processes that ensure these systems are truly robust and reliable, especially when we're talking about things like our health data or financial transactions.
Absolutely. And remember, this is still a relatively young technology. As private blockchains become more prevalent, so will the need for even more sophisticated testing methodologies and tools.
It's like a constant evolution, with developers and testers working together to stay one step ahead of any potential problems.
Exactly. And as an informed individual, being aware of these developments is key to navigating this evolving landscape. Now, before we wrap up, I want to leave you with something to ponder.
Okay.
We've talked about how testing ensures trust in private blockchains. But as these systems become more integrated into our daily lives, how might our definition of trust and the ways we measure it evolve?
That's a really interesting question. It's like we're on the verge of a whole new paradigm of trust, one that's built on transparency, verifiability,
Hmm.
and this rigorous testing we've been discussing.
Precisely. And that, my friend, is something worth thinking about.
Indeed. It's been a fascinating deep dive into the world of private blockchain testing. Who knew there was so much happening behind the scenes to ensure these systems are truly reliable and secure?
It's an intricate process, but one that's absolutely essential as this technology continues to shape our world.
Well, thanks for guiding us through this complex landscape and for giving our listeners the tools to understand and evaluate this technology for themselves. Until next time, stay curious and keep exploring.